I did not expect anything unusual when I first stood outside the Holborn Viaduct Station building on Charterhouse Street in London, officially completed in 1865 as part of the London, Chatham and Dover Railway expansion. The Victorian infrastructure is well documented. The archives are thick with drawings, budgets and committee notes. I assumed this would be another confirmation exercise. In the British Library's digitised collection, I found an 1870 construction photograph. Workers posed beside a brick facade meant to conceal service corridors beneath the roadway. What caught my attention was not the tunnel mouth, but the stone symmetry above it. Load-bearing arches aligned to tolerances tighter than contemporary rail standards, resting on masonry blocks weighing several tons each. A renovation record from 1921 quietly noted, lower passages sealed, hydraulic remnants removed, no diagram followed. Some researchers classify similar buried systems as Tartarian infrastructure, structures inherited, not built. At first I dismissed that idea, then I measured the arch radius. Something here did not belong to 1865. An ordinary Victorian claim begins to fracture the moment you look closely enough. The official histories describe Holborn Viaduct as a triumph of Victorian engineering, brick, iron, steam and civic ambition stretching across the Fleet Valley. Railway Committee minutes from 1862 credit engineer John Fowler with the design, a familiar name in London infrastructure circles, competent and methodical. Nothing in his published work from that period suggests experimental approaches to underground hydraulics or pressure-balanced tunneling systems. Yet in an early street-level photograph dated 1867, now held in the London Metropolitan Archives, the visible tunnel lining shows perfect bilateral symmetry. Not merely left-to-right balance, which would be expected, but mirrored proportions across successive arch segments with variations measuring less than 2 centimeters across a 12-meter span. Victorian tunneling of the 1860s typically tolerated far greater variance, hand-cut brickwork, mortar inconsistencies, settling over time. This did not settle, this did not vary. I found the first hint of something deeper in a maintenance sketch tucked into a London County Council binder dated 1894. The sketch depicts a sealed side chamber labelled only former conduit, purpose unknown. No dimensions, no materials list, just a penciled outline showing walls thicker than any documented service tunnel from the period, and a notation reading infilled per order, August 1894. Some researchers in alternative history circles argue that Victorian railways frequently reused pre-existing corridors, structures they attribute to a Tartarian civilization that once spanned much of Eurasia. I was not ready to accept that interpretation, but the geometry forced a pause. If this was merely a service tunnel for gas lines or drainage, why design it with the load distribution characteristics of a pressure-balanced hydraulic system? The arch curve matched calculations for fluid dynamics, not pedestrian traffic. Decorative tunnels do not require this degree of mathematical precision. City renovation logs from 1907, preserved in the Camden Local Studies and Archives Centre, note a single line reading brick infill applied to redundant access point, Charterhouse Street subgrade, March 14th. No accompanying explanation, no engineering assessment. The access point still exists today, visible as a shallow stone recess behind later electrical conduit housing, approximately 2 meters below current street level. An 1881 photograph taken during gas main installation shows this doorway open. The image quality is poor, but the details are unmistakable. Inside, the floor slopes downward at a gradient of roughly 1 in 15, far too steep for standard drainage of the period, which typically used gentler slopes to prevent erosion. More troubling, the walls visible in the photograph are lined with dressed stone blocks, not brick. The stone surface appears smoother than any municipal tunnel I have documented from London's Victorian era, with joints so tight that mortar lines are barely visible even in the photograph's lighter exposures. A marginal note in an engineer's field notebook from 1906, archived separately, reads, "Mechanism removed prior to inspection, no record of original installation found." This echoes descriptions I had encountered in Tartarian research literature, accounts of repurposed subterranean levels sealed once their original function was no longer understood by later occupants. The language is eerily similar. Unknown mechanisms, absence of installation records, deliberate sealing rather than adaptation. I had initially assumed this was simply Victorian over-engineering, the kind of excessive structural investment that characterized the era's public works. Over-engineering, however, generates documentation. Engineers proud of innovative solutions write papers, civic authorities commission reports, contractors submit detailed invoices. Here, there was only absence. Why remove something before inspecting it? Why not document what you found? Before continuing underground, I returned to maps. Cartography sometimes preserves truths that later construction obscures. An early London plan from 1748, held in the British Library's King's Topographical Collection, shows no tunnels beneath the Holborn area. This is unsurprising. The district was largely undeveloped farmland and scattered buildings at that point. An 1801 revision of London, however, adds something unexpected. It shows unlabeled voids beneath several major roadways, marked only with dotted lines and no accompanying text. By the time railway planning documents appear in 1860, these same spaces are claimed as new excavation sites for the London, Chatham and Dover railway expansion. But if they were new excavations, why did the 1801 map show them? I found a potential answer in an unexpected source. A Dutch commercial atlas from 1707, digitized by the Rijksmuseum, labels vast territories across Eurasia as Tartaria, a designation that appears on European maps well into the 19th century. What caught my attention was not the territorial labeling, but the cartographic symbols used for cities within those regions. The mapmaker employed identical iconography to denote subsurface features, geometric grid patterns beneath major urban centers, drawn with the same dotted line convention I had seen in the 1801 London map. The correspondence was too specific to dismiss as coincidence. Different mapmakers, separated by nearly a century, used identical symbolic language to represent underground infrastructure. I am not claiming London was part of a Tartarian empire. The historical evidence for that is non-existent. But the mapping language itself suggests shared knowledge of subgrade systems, geometric layouts that preceded the documented construction dates of Victorian tunnels. The Victorians may not have invented these systems. They may have simply found them, measured them, and built around them. Maps sometimes preserve truths that buildings are designed to conceal. Original engineering plans for the Holborn Viaduct tunnel network, archived at the Institution of Civil Engineers, show remarkably simplified cross-sections. The drawings depict standard brick barrel vaults, basic drainage channels along the tunnel floor, and gas pipe conduits along the walls, exactly what you would expect from an 1863 infrastructure project. But the construction photographs tell a different story. In an image dated October 1864, visible in the London Metropolitan Archives Railway Construction Series, the tunnel interior shows stone ribbing, not decorative but structural. These ribs are embedded beneath later brickwork, visible where the brick facing has not yet been applied. More significant, iron anchor points forged with ring bolt housings are set into the stone at regular intervals. Those anchor points are already in place in the photograph, which means they predate the Victorian brickwork installation. The engineering drawings from 1862 show none of this. A private engineering journal entry dated March 1864 and preserved in the archives of the Royal Society of Arts includes a complaint from a site foreman, The note reads, "Encountered unexpected subsurface resistance in the western approach. Stone foundation of unusual depth and composition. Delayed excavation by 11 days while determining safe methods for partial removal and integration." Unexpected to whom? If John Fowler's team had designed and excavated these tunnels from scratch, there should have been no surprises about what lay beneath the surface. The foreman's note suggests they found something already there. Researchers investigating Tartarian infrastructure argue that 19th century builders often drew inherited plans that deliberately omitted inherited structural elements, not out of conspiracy, but because acknowledging them would have raised uncomfortable questions about construction budgets and project timelines. Why pay engineers to design something that already exists? This would explain the mismatch between the engineering drawings and the photographic evidence. If you drew something simpler than what you actually built, no one would ask why the construction took longer or cost more than the drawings suggested. A maintenance ledger from 1889, discovered in the London County Council Engineering Department records, references pressure equalization chambers in a pedestrian underpass connecting Holborn Viaduct Station to Farringdon Street. The entry is brief. Inspection of pressure equalization chambers, Southern Passage, November 12th. No active flow detected. Recommend sealing. I examined period maps. No water mains are listed near that location in 1889. No hydraulic power systems. No pneumatic railways. The nearest documented water infrastructure was more than 100 meters away, serving completely different buildings. Pressure equalization is a term from hydraulic engineering. It describes systems designed to balance fluid pressure across multiple chambers or channels, preventing destructive surges. It appears in contexts where water, steam, or compressed air flows through networks under controlled pressure. Why would a pedestrian underpass require pressure equalization? I began searching for similar language in archives from other European cities. In St. Petersburg's Municipal Engineering Archive, a renovation report from 1891 describes closure of pressure distribution nodes beneath Nevsky Prospect, original purpose uncertain. In Paris, the Archives de Paris holds a document from 1887 noting sealed hydraulic chambers, Rue de Rivoli subsection, mechanism non-functional and removed. Vienna, Berlin, Budapest, Prague. The same phrasing appears across documents spanning 2 decades. Pressure chambers, hydraulic systems, distribution nodes. Always described as obsolete, always sealed rather than repaired, and always the qualifier, original purpose unknown. Alternative researchers examining Tartarian infrastructure have noted this pattern. They argue that the terminology itself is evidence, and that engineers across Europe encountered underground hydraulic networks they could measure and map but could not fully understand. The language persists in official records, but the explanations do not. No one documented what these systems were for, only that they existed and that they were systematically decommissioned. Terminology can outlive the knowledge that created it. We still use words whose original meanings we have forgotten. Perhaps we still walk above systems whose original purposes were never recorded. I turned my attention to Paris. If similar language appeared in French engineering records, I wanted to see if the physical infrastructure matched what I had found in London. An 1874 renovation photograph from beneath the Passage de Panoramas, held in the Bibliothèque Nationale photographic collection, shows tunnel arches during gas line installation. The arch construction is immediately recognizable, the same radius curvature as the Holborn Viaduct tunnels, measured at 3.4 meters from the spring point to the crown. When I overlaid scaled tracings of both photographs, the arch profiles aligned within millimeters. Different builders, different cities, different decades of construction, same geometry. The Passage des Panoramas tunnels are credited to French engineer Jean-Baptiste Krantz, whose work on Paris infrastructure is well documented. But his field notes from 1873, preserved in the Archives Nationales, include an unexpected observation: existing stone encountered during excavation, adapted foundation to accommodate. Adapted to what? The note does not specify. But the photograph shows what he found: dressed stone blocks forming the tunnel base already in place when his crew arrived. The blocks are visible beneath the newer iron support beams added during the 1874 renovation. This was no longer an isolated anomaly confined to London. The same architectural signature, identical arch geometry, precisely matched curves, stone infrastructure predating documented construction, now appeared in two capitals separated by more than 300 kilometers. Researchers examining Tartarian architectural patterns have noted this phenomenon across dozens of cities. They describe it as evidence of a standardized building system, modules and proportions reused across vast distances with remarkable consistency. The consistency, they argue, suggests a coordinating authority or shared engineering knowledge that predates the nation-states of the 19th century. I was not prepared to accept that conclusion, but I could not ignore the measurements. Standardization of this precision requires an earlier standard, something that established these proportions before Victorian and Second Empire engineers began their work. The question is no longer whether these systems exist. The question is when they were first built and by whom. Vienna provided the next piece. The Karlsplatz transport hub, completed in the 1890s, sits above vaulted chambers that city records attribute to the infrastructure expansion accompanying the Stadtbahn construction. Official documentation dates these vaults to the early 1870s, with major work completed by 1878, but a daguerreotype from 1842, preserved in the Wien Museum's photography collection, shows the vault already present. The image captures a street scene during early gaslight installation, with workers, horse carts and cobblestones. In the background, partially visible through an open excavation, is the distinctive curve of a vaulted chamber. The stonework is unmistakable, the same dressed blocks, the same joint precision, the same arch geometry I had already documented in London and Paris. This vault predates the Stadtbahn by more than 30 years. It predates Vienna's major 19th century infrastructure expansion. It even predates the invention of photography itself by only a few years, which means the structure was already old when the daguerreotype was taken. More troubling, the vault includes iron fittings visible in later photographs from the 1890s, when portions of the chamber were exposed during tramline construction. These fittings, ring bolts, mounting brackets, and structural reinforcements are forged to tolerances inconsistent with early 19th century metalworking. The precision suggests mid-century industrial manufacturing techniques, but the vault's presence in the 1842 photograph proves the fittings must have been installed earlier. Tartarian researchers describe chambers like these as nodes in a larger distribution network, possibly for water, possibly for steam, possibly for functions we no longer recognize. The designation remains speculative, but the physical evidence is not. These vaults exist, they are older than their official construction dates, and they incorporate engineering precision that should not have been achievable with the documented technology of their era. City records can be revised, construction dates can be reassigned, but photographs do not lie about what existed when the image was captured. Dates written on paper do not move stone, and stone, once photographed, cannot be backdated. By the time I began systematically reviewing renovation records from 1890 to 1930, A pattern had become impossible to ignore. Across London, Paris, Vienna, and Berlin, municipal engineering departments followed an identical procedure when encountering unexplained underground chambers. First, discovery during construction or maintenance work. Second, brief documentation, often a single line noting location and dimensions. Third, classification as obsolete or redundant, regardless of structural condition. Fourth, sealing with brick infill or concrete. Fifth, removal of any mechanical components found within. A directive from the London County Council dated April 1903 states explicitly, mechanical remnants of uncertain origin removed from subsurface chambers, Clerkenwell District, materials disposed of per standard protocols, not repaired, not studied, not catalogued in any accessible archive, removed and disposed of. The language is bureaucratic, emotionally neutral, procedurally routine. There is no indication of conspiracy or deliberate suppression. What comes through instead is administrative discomfort, the kind of institutional response that occurs when something does not fit existing categories. If you cannot classify it, if it contradicts the accepted timeline, if it raises questions you cannot answer, the simplest solution is removal. Tartarian researchers describe this period as systematic erasure, though not in the sense of organized conspiracy. Rather, they argue it represents bureaucratic inertia applied to infrastructure that no longer served an understood purpose. Cities were modernizing, electric systems replaced gas, steel construction replaced stone. Anything that seemed obsolete, even if its original function was unclear, was simply cleared away to make room for newer systems. But obsolescence implies prior function. And if these chambers and mechanisms served no known purpose by the early 1900s, the implication is that they once served a purpose that had been forgotten. What kind of knowledge disappears in less than a century? What systems become incomprehensible to the people who inherit them? The question is not why these chambers were sealed. The question is why no one documented what they were for before sealing them. If you erase what you cannot explain, you also erase the possibility of understanding it later. Budapest's underground thermal system, officially constructed in the late 1870s to harness the city's natural hot springs, presents another architectural impossibility. The system's distribution chambers, documented in city engineering records from 1878, utilized dome structures, not merely curved ceilings but precisely engineered hemispherical vaults designed to distribute pressure evenly across the chamber walls. Domes underground serve no aesthetic purpose. They exist for structural reasons, to manage compression loads, to resist soil pressure, or to regulate internal air pressure in sealed environments, a fundamentally structural choice. But the Budapest thermal chambers were never sealed. They were open distribution nodes, moving hot water from spring sources to public baths and municipal buildings. A dome structure in this context would be unnecessary unless the system was originally designed for pressure regulation beyond simple water flow. More significantly, the dome geometry matches surface structures commonly associated with Tartarian architecture. The same proportional ratios, height to diameter, curve profile, keystone placement, appear in domed buildings across Eurasia, from Orthodox churches to Central Asian bathhouses. These are not approximate similarities, the proportions are striking. Tartarian architectural researchers have long argued that dome structures served functional purposes beyond religious or aesthetic considerations. They propose that domes acted as pressure regulators or environmental control elements within larger systems, possibly hydraulic, possibly atmospheric, possibly something we no longer recognize. I cannot confirm that interpretation, but I can confirm the measurements. The underground domes of Budapest align precisely with the proportions of surface domes attributed to Tartarian design traditions. The measurements are consistent. Form follows function. Even underground, architectural choices reflect engineering requirements. If you build a dome where a flat ceiling would suffice, you are solving for a variable that flat geometry cannot address. The question becomes, what variable, what pressure, what flow, what environmental condition required hemispherical vaulting in chambers moving hot water from point to point? The variable is unknown. The thermal system still functions today, but the domes remain, serving a purpose that current operators do not require, and historical records never explained. Turin's underground defences, mapped during the Italian unification period around 1860, present yet another anomaly. Military engineers surveying the city's foundation structures discovered geometric layouts beneath the streets, specifically angular patterns resembling starfort construction, the distinctive pointed bastion architecture commonly associated with both military engineering and Tartarian urban design. Starforts on the surface make strategic sense. The angular bastions allow defensive fire along multiple axes, eliminating blind spots and maximizing coverage. But starfort geometry underground, built into the foundation layer beneath civilian streets, serves no obvious defensive purpose. You cannot aim cannons through earth and stone. You cannot defend against siege weapons from below street level. Yet the geometry is unmistakably starfort in character. Five-pointed radial symmetry, angled walls meeting at precise vertices, proportional spacing that matches surface starforts documented across Europe and Central Asia. The symmetry is clear. The foundation layouts predate Italian unification, and that is clear from the construction materials and masonry techniques. But city records provide no explanation for why subsurface infrastructure would adopt military defensive geometry. There are no documented underground fortifications in Turin's official history, no siege preparations that would justify this layout. There are no military engineering projects that match the scale and precision of what the surveys revealed. Tartarian researchers point to similar discoveries in other cities, Moscow, St. Petersburg, Prague, where subsurface infrastructure incorporates defensive or fortified geometry despite serving no defensive function in the documented historical record. They interpret this as evidence of repurposed structures, foundations built for one purpose, later adapted by civilizations that no longer understood the original design intent. If you inherit a starfort foundation, you might build a city on top of it. You might use the existing stone as a base for newer construction. But would you understand why it was shaped that way? Would you document a purpose you could not comprehend? Or would you simply note existing foundation encountered and proceed with construction, leaving the underlying geometry unexplained in official records? Defense against what, above ground or below? The geometry suggests a threat, but no records name it. When I overlaid scaled maps of underground corridors from London, Paris, Vienna, Budapest and Turin, proportional ratios emerged that should not exist. The arch heights relative to passage widths held constant across all 5 cities, approximately 1.7 to 1. The spacing between structural support points repeated at 4.2 meter intervals, with variations under 10 centimeters. Wall thicknesses averaged 0.8 meters, regardless of soil conditions or documented load requirements. This is not close similarity, this is standardization. But standardization requires coordination, shared engineering specifications, common measuring systems, centralized design authority. The cities in question were under different political control throughout the 19th century. They used different measurement standards, English feet, French meters, Viennese clafters. They had no unified engineering schools, no international design codes, no mechanism for coordinating infrastructure specifications across national boundaries, yet the proportions matched. Tartarian maps from the 17th and 18th centuries often depict cities as nodes within a broader network. trade routes, yes, but also something more systematic. The cartographic symbols suggest interconnection beyond commerce. Researchers examining these maps argue they represent administrative or infrastructural networks, cities built according to common standards, linked by more than roads. I had resisted this interpretation for months. The measurements, however, did not care about my resistance. The proportions repeated regardless of whether I accepted the implications. When you find identical architectural ratios across a continent, separated by distances that would have taken weeks to cross in the pre-industrial era, you face two possibilities: either multiple engineering traditions, independently developed identical standards through pure coincidence, or they inherited those standards from a common source. Coincidence does not repeat at this scale. Coincidence does not hold to millimeter-level precision across thousands of kilometers. Something unified these systems before the nation-states claimed them. Something established these proportions before Victorian engineers began documenting their new excavations. Whether that something was Tartarian, as the maps suggest, or some other coordinating force, the evidence no longer supports the claim that these systems were independently invented in the 19th century. They were found, measured, reused, and the original builders were never named. Victorian engineers were undoubtedly skilled. The bridges, tunnels, railways, and viaducts they built across Britain and Europe remain functional more than a century later. Their competence is not in question, but the documentary record shows adaptation, not invention. They laid rails through corridors already present. They lined existing tunnels with brick. They installed gas pipes in chambers they did not excavate. When they encountered stone blocks too large to move with available equipment, they built around them. When they found mechanical components they could not identify, they removed them and noted only remnants of uncertain origin. This pattern of encounter, adaptation, and obscuration aligns precisely with what researchers examining Tartarian hypotheses have proposed: a prior civilization with infrastructure that exceeded later industrial needs, repurposed by successor societies that no longer understood the full purpose of the original systems. The evidence does not prove a Tartarian origin. Proof would require maker's marks, construction records, cultural artifacts directly linking the infrastructure to a documented Tartarian state. Those records do not exist, or they have not survived, or they were never created in forms we would recognize. But the alternative, that Victorian engineers independently built identical systems across Europe, using precision beyond their documented capabilities, and then systematically failed to document or claim credit for these achievements, strains credibility more than the inheritance hypothesis. When you inherit something, you do not always understand what you have received. You adapt it to your current needs. You describe it in your own terms. And if it contradicts your understanding of how things should work, you classify it as anomalous and move forward. This is not suppression. This is institutional momentum applied to uncomfortable data. The question is no longer whether these systems represent inherited infrastructure. The measurements have answered that. The question is whether we are willing to reconsider the timeline we have accepted, whether the 19th century was an age of industrial innovation or an age of industrial adaptation applied to foundations we did not build. Inheritance explains the silence better than invention. Silence is what happens when you cannot explain what you found. I returned to Holborn Viaduct 18 months after beginning this investigation. The sealed doorway was still there, behind the electrical conduit housing, exactly as it had been in the 1881 photograph. Nothing had changed in the physical space, but I saw it differently now. It was no longer a minor Victorian service passage. It was no longer an over-engineered access point built by ambitious but conventional railway contractors. It was a node, one point, in a system that stretched beneath London, beneath Paris, beneath Vienna, Budapest, and Turin, invisible to the millions who walked above it daily. The 1870 photograph showed workers posed beside the tunnel entrance, proud of their construction project. But the arch above them, the stone blocks they stood beside, the hydraulic remnants that would be removed in 1921, none of that belonged to them. They were maintenance workers, not builders. They were adapting systems they could measure but not replicate. The Victorians did not build over nothing. They built over something they chose not to name, perhaps because naming it would have required acknowledging that their new infrastructure was merely renovation work on foundations that preceded their civilization's claimed technological capabilities. Whether those foundations were Tartarian, as the historical maps and architectural proportions suggest, or whether they represent some other lost engineering tradition, the conclusion remains the same. We have inherited cities built on infrastructure we did not create, maintained by records that obscure more than they reveal. The sealed doorway remains closed. The hydraulic chambers remain filled with concrete. The mechanical components remain disposed of in long-forgotten rubbish heaps. And beneath our cities, geometric systems still distribute loads, regulate pressures, and maintain structural integrity according to principles we no longer teach, designed by engineers we have never named. The last photograph is the 1870 image again, the workers, the tunnel, the precise stonework. This time, I do not see Victorian triumph. I see inheritance, quietly repurposed, carefully unnamed, systematically adapted to needs smaller than those for which it was originally designed. What lies beneath our cities is not empty, it is silent, and silence in architecture is rarely accidental.